Okay? All right, so pretty easy stuff. We're gonna write the parametric equations of the line. Now, if I gave you 2 points, like 2, 3, and 5, 8, you could write the equation of a line, right? What would be the first thing that you would do? You would find the slope. And you would find the slope rate of change by doing this y minus this y over this x minus this x. Right? And you get 5/3. Now, what does that tell you? That tells you that your line is moving from point to point, up 5 and right 3, right? And then up 5 and right 3 again, and up 5 and right 3 again. So it's moving in multiples of up 5 and right 3. When we write lines parametrically, we think of them as a vector motion. So let's say this line, I'll just say xy. The points on the line start at, let's say, 2, 3, and they move in multiples of up 5, right 3. Now I have to write it this way because when I write an x comma y, x comes first. So this tells me that the x motion of my line is right 3 and the y motion is up 5. So if you think about this for a second, if we let, thank you, raise your name off the board over there, and I won't come hunt you down.
Thank you.
Okay.
Have a good one.
You too. Go, sirs.
Sirs at 7.
Okay. That's what he calls the pacers. He has a whole different language he uses. I don't understand what he said. Okay, so you told me that this line moves by taking steps that are the ratio. Love you.
I'll see you. Are you coming to our open house?
I'm gonna try.
Please.
I will.
I'll bring a slip and slide.
No, I won't do that. Right 5 and up 8. Or excuse me. Up 5 and right 3. That's how our line moves. So if we put a 1 in here for t, then we would have 2 plus 3, which would put us at 5, and 3 plus 5, which would put us at 8. Well, what would happen if we put a 2 there? Well, we would get the next point on the line, the next whole point on the line, right? So this is called the vector representation of a line because it gives us a starting point and then tells us how to move in multiples of 3, 5. If we separate that, we get x equals 2 plus 3t. See what I did? I just took all the x parts of the equation, and y equals 3 plus 5t. These are called the parametric equations for the line. Okay? Done. T is the parameter, any real number. So these two things, equations, will generate the points on the line through these 2 points. Okay? All right, so you try B. What are the parametric equations of this line? So are you finding your slope first? Because you have to know how the line moves. So this line, I think, moves up 4, right 1? So that's how the line moves. Multiples of that movement will generate the whole line. What's this? that is my starting point. You can't just tell me you have a slope of 4. You have to tell me starting where. I picked this point. Could I have used this point? Yeah, in fact, this can be any point on the line, and then this can be any multiple of the slope. So if this had been 2/8, would that be okay? Absolutely. Now, we normally keep it in the smallest terms, but it would be okay. So I said x equals 5 plus t, and y equals -3 plus 4t. But again, I just always use this point, but I could have used this one, or any other point on the line. All right, there's one more. Go ahead and do it all by yourselves. I'll do it too on my paper here, and we'll see if we get the same answer. What'd you come up with? X equals
4 plus 32.
y equals?
0 plus 2.
Good. Everybody okay with that? Okay. So now we're going to do it backwards. Write the Cartesian form. Now the Cartesian form of the line is what you're used to. Y equals mx plus b. Something like that. Cartesian x and y. So, any thoughts on that? There's a couple different ways you can do it. Do you have any ideas?
First, I know that one of the points is 2.
Okay, so Jordan says, I can tell by my knowledge of parametric equations that this right here is one of the points on the line. What's this right here? The rate of change, which is slope, right? So what would our slope be? 3/2. Perfect. And then you can write the equation of the line. So this is one option. This is one option. So I got 3/2 x minus 4. But double check that. Does that look okay? That is beautiful. Nothing wrong with it at all. Does anybody have a different idea? Well, what if I solved, this is like a system of equations. What if I solve this for t? So x minus 2 over 4 equals t. Does that make sense to you? X minus 2 divided by 4. And y plus 1 over 6 equals t. What could I then do? Set them equal to each other. So that would be x minus 2 over 4 equals y plus 1 over 6. This is going to look a little bit different, but is that the same equation? I'm going to go ahead and divide. Is that the same equation as what we came up with the first time through? Yeah, if we get y by itself. Isn't it exactly the same equation? So a couple different options there. I love what you guys did first. I love that. That's absolutely great. You can also solve for t and set them equal to each other. Perfect. Okay, get your calculators out now. I think we may have talked about this already at some point, but maybe not. It's kind idea in unit 4, and it carries through the whole thing. This idea of implicit functions. Now, can you tell me what that is?
Circle?
That's a circle. Now, can you type that in on your calculator? In graph it, I mean. Can you type it in graphing mode? How would you do that? Right, because when I go to type something in on my calculator, doesn't it have to be y equals? So, that's what we mean by the implicit functions. Kids, this is not a function. This is a circle. You told me it's a circle. It's not a function. You're not going to be able to graph a non-function on your calculator unless you put it into some other form, like polar form or something like that, where it can graph all that. This isn't going to graph in regular y equals. It's a y equals equation. It's not going to graph that way because it's not a function. So, what we do is solve for y. Now, when you solve for y, so first of all, I'm going to subtract this guy to the other side. Would that be okay with everybody? Now I'm going to square root both sides, and I'm not going to make silly Algebra 1 mistakes. I'm going to square root both sides. That does not mean the square root of 8 and the square root of this. You're square rooting the entire side. So it's got to stay like that. There's no simplifying you can do. I mean, you could FOIL this out and there'd be some collecting like terms and stuff, but you're not going to be able to simplify that radical. And when you square rooted, you have to have plus or minus. Always, 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 right? Now let's add the 1 over, and the 1's going to stay outside the radical. Now this is 2 equations. Would you agree with that? It's the positive one and it's the negative one. Now, let's graph just the positive one. So go ahead and type that. See if you can type that in on your calculator. Watch your parentheses. I think you can do it. Did you get it in? What did it graph? Half the circle. So in the beginning, this thing is not a function, but because it's a circle. But if you split it into its 2 pieces, is that a function, what you just graphed? What do you think this is going to be? The bottom half? And those individually are functions. They're called the implicit functions. So this thing is not a function. But within it are 2 things that are functions, the top half and the bottom half of the circle, okay? Now, I'm not exactly sure why, there's some kind of quirkiness. Probably when you graph this bottom one, they're not gonna hook up. They really should. I don't know what's with the calculator, I don't understand it all. But the 2 halves should hook up. But probably there'll be a gap. All right, perfect, perfect, perfect. All right, can you do the same thing for problem B? This is not a function. Think about that for a second. Kind of a tricky one. This guy factors, guys, I know it's freakish, when you look at all that as x's and y's floating around, but how does this factor, McKenna? Y minus x. Now, can we square root both sides? So y minus x equals plus or minus 2. So what are my implicit functions? Y equals x plus 2 and y equals x minus 2. So as crazy as it seems, what does that look like? What is that picture? Isn't it a couple of lines? And what about those 2 lines? They are parallel? Isn't that crazy? That is crazy. Okay, one more. Do C. I think you can do C by yourself. Find the implicit functions and then go ahead and graph that one. That should be another circle. Do you have a little circle that didn't connect? Those were my implicit equations. Is that what you came up with? Implicit functions? Okay, everybody okay with that? We're gonna come back to this, cause now we're gonna look at some, like these were circles. Well, that one wasn't. But these other ones were circles. We're gonna look at the other conic sections now. We're gonna spend a little time with the parabola, write some implicit functions for that. We'll do the ellipse and the hyperbola. Okay, so are those words familiar? I know parabola is, since we spent time with parabola. I want to transition you a little bit. When we looked at parabolas, quadratic functions earlier, we looked at them like this. We said this was a transformed parabola. His vertex was at -1, -4, opened up. Am I speaking a language you understand? Okay. I'd like you to think about that equation though in a different form. I'd like you to think about that equation. Let's add the 4. And multiply by 4. Now, first of all, is that the same equation that I started with? This one has been shifted right 1 and down 4. This one has been shifted right 1 and down 4. So that is called the vertex of the parabola. So we're gonna look at a couple of the defining characteristics of a parabola. I'm gonna define it for you here in a minute. So -1, -4 is called the vertex or the turning point of the parabola. We know that this number out here impacts the vertical, that's like your A in all the equations that we do, it impacts the vertical stretch height of the picture. So this one has been multiplied by 1/4, which actually means it's probably gonna be a little bit fatter than normal, kind of compressed a little bit. Well, that 1/4 now shows up as a 4 over here. And that number right there is really, really important. If that number is positive, then our curve opens the way it originally did, which would be up. So this parabola is going to open up. Now, where it says parabola equals, I want you to write the definition of a parabola. A parabola is a set of points in a plane equidistant from a given point and a given line. And that given point and given line are in the plane also. So that is the definition of a parabola. Up until now, we've talked about parabolas in terms of that they're the graph of a quadratic function. X squared, they're always gonna have an X, or they're gonna have something squared in them. But now we're talking about it more in terms of its analytic definition. Set of points in a plane equidistant from a given point and a given line. Now, a given point is called the focus. Have you ever heard that word before? The focus of the parabola. I didn't know she talked about that last year. It doesn't sound familiar. And the given line is called the directrix. Your job is going to be to take an equation of a parabola and find the focus and the directrix of the parabola. Now, here's what the definition means. I'm going to show you, I don't know where they are exactly, but the focus will be there and the directrix will be here. So what the definition means, my picture is not very good. What the definition means is that if you pick a point on the parabola, that distance and that distance are the same. Again, my picture's not very good, but that's what it means. So if you pick another one up here, that distance and that distance are the same. We are equidistant from the given point and the given line. Now, if you have the equation, you can find the focus and the directrix, and it is not that hard. It requires you to remember something, but it isn't that hard. Okay? So here's the deal. This line right here is called the axis of symmetry, or the line of symmetry. Your focus is going to be on it. So clearly my focus is going to have an x-coordinate of -1. The distance that you go up to get your focus is referred to as P. I don't know why. Google it, probably figure it out. That's called P. In every equation of every parabola, once you get it in this form, doesn't work in that form, gotta be in this form, where your squared is by itself, this number, this coefficient, is always 4p. That number, whatever it is, whether it's 8 or a half or 37, doesn't matter, it's always 4p. So if 4p is 4, then p is 1, and you are going to go up 1 for your focus. So if we started our vertex and go up 1, where are we going to be? -1, comma, -3. And keeping in mind that the definition is equidistant, if you went up 1, for your focus, you're gonna go down 1 for your directrix. Now, it is a line, so what would the equation of that line be? Y equals -5. Now, this number is super important. Not only does it tell you how far it is from your focus to directrix, or from your focus to your vertex, but it also is the focal width. That number is the focal width. Now, anybody want to take a guess what the focal width of a parabola is? It's the width of the parabola through the focus. So, obviously that's supposed to be in the middle of my picture, is just horrific. But this width is 4. The bigger the focal width, the wider your parabola is going to be, right? And remember in the beginning you told me this was going to be wide? Well, it is wide. It's 4 across there. So your job was to find the vertex, found it, focus, directrix, and focal width. You did it all. And you did it great. All right, let's look at the next one. The equation is not written right. We want to get our squared term by itself. Oh wait, it is written right. The squared term is by itself, it's backwards. Perfect. This equation is ready to go. Where's the vertex? Any idea? -2, 3. I love it. Thank you, McKenna. She did not fall into the trap. When you write down a point, isn't it always x comma y? Yeah. So no matter equations backwards, doesn't matter, it's -2, 3. Now, what's different about this one? Look at y is squared. How do you think that changes things? That's a big change. How do you think that changes it?
Is it opening?
It opens sideways, exactly. And since that number is positive, it's gonna open to the right. Remember the x squareds positive were up? Well, y squared positives are right. So this thing is opening to the right. It is not a function. And that's why you'll notice that the very next problem is we're gonna write implicit equations for it so that we can graph it on our calculator. Okay, we're just doing a hand sketch right now. Okay, now, here's my axis. My focus is inside the curve somewhere. I'm just randomly putting it there. It's somewhere in there. And the directrix is somewhere back here. Would you agree with that? Now, tell me how far it is from here to here. We call that distance P. And how do I find P? 4P is 1/8. This number right here, when you get your squared by itself, that's the key, get your squared by itself. This coefficient right here is always 4P. So P is 1/32, right? So you're gonna start here, and you're gonna go forward 1/32. Okay, so what is that? -2 plus 1/32. Negative what? 63/32, comma 3. If you wanted to use a mixed number, you could also say -1 and 31/32. And if you went forward 1/32 for your focus, then you're gonna have to go backward 1/32. This is a line, x equals negative 65 30-seconds, or negative 2 1/32. And what's our focal width? 1/8, which means this guy is pretty darn skinny. Everybody okay? All right, let's take this equation that we just used right here, and let's find the implicit functions for it, and then we'll graph it on our calculator. All right, so what are we gonna do? What are we gonna do to this guy right here? Square root it. So y minus 3 equals plus or minus the square root of 1/8 x plus 2. So y equals 3 plus or minus the square root of 1/8 x plus 2. All right, let's see if we get a nice little sideways parabola when we graph these. This time I put the number at the front. You can always put the number at the end if you want, it doesn't matter. Did you get what we thought? Did we? Good? Everybody good? Okay. D, we're gonna do a couple more here. D. Is this a parabola? Yes. The equation of a parabola will have how many, it has x's and y's in it. You gotta have x's and y's. How many of them are squared? Are they both squared? In a parabola, only one is squared. In all the other conic sections, circle, ellipse, hyperbola, they'll both be squared and have different relationships to each other. But in a parabola, only one is squared. So this is a parabola. Furthermore, it's an x squared parabola, which means it's going to open up or down. And since that number's positive, it's going to open up. All right. So your job now is to find the vertex, focus, directrix, focal width. Find it all, just like we did before. Got a couple different strategies. Can we make that equation look like this? I think we can. How about if we add 5? So far, so good. And let's factor out the 2. And I'm going to go ahead, I'm going to take that 2 out, so I have x squared plus 3x. And then I'm going to go ahead and leave a blank there, and I'm going to have to put that blank over here too. And I'm going to complete the square so that I have a squared quantity. So do you remember how to do that? How do we complete the square? Half of this squared. Okay, so what's half of 3? 3 halves. 9/4. Now be careful, this is an equation. So if you add something over there, you gotta add it over here too. What am I adding over here? Be real careful. 9 halves, very good. Why am I adding 9 halves? Because the 9/4 is being times by 2 on the right. Now, this is x plus 3 halves quantity squared. That's why you did it, because you needed a quantity squared. And over here, we've got y plus, what is that, 19 halves? Now I need my squared by itself, so I'm gonna go ahead and bring that 2 over. So I'm gonna have 1/2 y plus 19 halves equals x plus 3 halves squared. There's a lot of arithmetic going on there, guys, so I'm gonna stop right there and make sure everybody is still on board. We started with that, and we did a bunch of junk and ended up with this. Got it? We're okay? All right, where's my vertex then? So -3 halves, -19 halves. My picture, I'm only using it as a reference. I'm not grading a picture. Nobody's grading your picture. I just like to, personally, I need to visualize it. So there's my vertex. We already decided, didn't we, that it was gonna open up because it's x squared. X squareds are functions, they open up and down. That's a positive number, so it's up. Here's my axis of symmetry. So my focus is here somewhere and my directrix is down here somewhere. They're always opposite each other. Focus is inside the curve, so if the focus is up, then the directrix is gonna be down. Can we figure out our focus? How far up are we gonna have to go? We're gonna have to go up P. And what's P? 1/8. So if we start at -19 halves and go up an 1/8, -75/8. Check my arithmetic, is that what you got? And if you went up an 1/8 to get your focus, then you're gonna go down an 1/8. So this is gonna be y equals -77/8. All right, one more, and then I got some extra practice for you to do. One more. We're going to look at writing our own equation. So we have a focus at -3/4. That's our focus now, not your vertex, that's your focus. And the directrix is out here at x equals 11. And we want to come up with an equation that looks like this one. So in other words, our equation is going to have some number of parentheses that isn't squared equal to a parentheses that is squared. So stop a minute and make sure that digests. This is the parabola we just did. This is the standard form of the parabola. Where do I even start? Well, I need the vertex, but even before I need the vertex, I need to know which way does this thing open? That's an important thing to know. It opens actually to the left, isn't it? It has to wrap around its focus. Isn't it gonna open something like that? Now, what does that tell me about my parentheses? If I'm opening left, then y is squared. And left is a negative. So whatever that number is out in front there has to be negative. Now, I just randomly popped this point up here. There would be my vertex, right? Can we figure that out?
It's in the middle of.
It's in the middle of -3 and 11. So we average those. To find the middle, we average. So -3 and 11 is 8. Half of that is 4. And it'll have the same y as this one, won't it? Because it's... Alright, so -4, -4. Now those happen to be the same number, so I don't really have to be too careful, but when they're not the same number, make sure you're putting the x with the x and the y with the y. Perfect, we're almost done. Now what?
You have to find
I gotta find p. Well, p is right here, right? Isn't this p right here? And what is p? From -3 to 4 is 7. So p is 7. Now, that number isn't p. That number is always 4p. So that number is a -28. And there you go. You've written your parabola. Okay. Now I got a little extra practice sheet for you. Oh, thank you, Mrs. Ford. This is what I wanted. And I want you to do a problem. You can do it right now, get as much done as you can, maybe get it all done. I want you to do problems 1, 2, 3A, and 3B. And let's do one more. Let's do 4A, I guess. So what is that? 5 problems? That's what I want. 5 problems. Don't want to overdo it. And then I said 4A, right? Okay, so you can work together. I don't have the answer. I don't have these worked out yet. I will work them out. We can check them.